subscribe my channel and press the bell icon for updation.
Hello, welcome SM Physics. Today we discuss about this problem here. A small body A starts sliding down from the top of a wedge as figure is given here, whose base is equal to L, that is given 2.10 meter. The coefficient of friction between the body and the wedge surface is mu equal to 0.140. At what value of alpha will the time of sliding be the least? That means you have to find out the minimum time to reach the body. What will be it equal to, and you have to find out the value. Okay. So you just take the screenshot of this figure. Now the body is here, and this one is the inclined plane. The body moves in the downward direction, and the frictional force is acting in the opposite direction between the contact point of the wedge and the block. Now here we apply the equation F is equal to ma. That is the mass into acceleration. First of all, the body moves in the downward direction. So the net force is act in the downward direction. That means mg sin alpha minus Fr, that is the frictional force, that is equal to ma. Now what is Fr? You know the frictional force Fr, that is equal to mu r. So mu and r, this component is equal to the mg cos alpha. So we can write r is equal to mg cos alpha. So Fr, that is equal to mu into mg cos alpha. I put the value of Fr in this equation, then we get mg sin alpha minus mu mg cos alpha, that is equal to ma. Now we eliminating the m from the both sides, we get g sin alpha minus mu g cos alpha, that is equal to a, that is the acceleration. Now the body moves this distance. So let this distance be h. So h equal to, suppose the body take t time from reaching the end position. So the formula will be h means L sec alpha, because L is given, this L is given, L sec alpha, that is equal to 0 plus half a t square. Now I put the value of a here, that is L sec alpha is equal to half into, within bracket we can write g sin alpha minus mu g cos alpha into t square. From this relation, you have to find out the value of t. T means 2L sec alpha, 2L sec alpha by g sin alpha minus mu g cos alpha. Again I repeat, the body is sliding down, and take the minimum time. You have to find out that minimum time. So when the body moves in the downward direction, so you have to find out the net force first. mg sin alpha minus Fr means the frictional force, that is equal to ma. Now mg sin alpha minus Fr means, already I deduced from here, Fr equal to mu mg cos alpha. So minus mu mg cos alpha, that is equal to ma. Now eliminating m from both sides, g sin alpha minus mu g cos alpha is equal to a. That means acceleration is find out. Now h, that means the body moves from this position to this position, let this distance be h. So h is equal to x L sec alpha, that is equal to 0 plus half at square. Put the value of a in this equation and then we find out the value of t. So you take the screenshot from here. Now t square is equal to 2l sec alpha divided by sec alpha divided by g sin alpha minus mu cos alpha. Now t equal to root over 2l sec alpha divided by g into sin alpha minus mu cos alpha. That means 2l divided by sec alpha means when it is coming down cos alpha. So g sin 2 alpha by 2 minus mu cos square alpha. Now you have to find out the least time taken by the block. So t means differentiate of sin 2 alpha by 2 minus mu cos square alpha by d alpha, that is equal to 0. This one is the minimum condition I am applying here. Okay, so you just take this screenshot, then I rub another thing and post it. Now t mean, that is equal to d of sin 2 alpha by 2 minus cos square alpha by d alpha. That means, now if you find out first the sin 2 alpha, that is 2 cos 2 alpha, 2 cos 2 alpha by 2, and then plus 2 mu cos alpha sin alpha, that is equal to 0. So I differentiate it and then I get this thing, 2 cos 2 alpha by 2 minus 2 mu cos alpha sin alpha equal to 0. That means tan 2 alpha, that means tan 2 alpha, that is equal to 1 by mu. Okay, so in the figure mu's value is there. Yeah, so 1 by mu means 1 by 1.40 something, and therefore alpha equal to 49. So you just take this screenshot and further I proceed. Now alpha equal to 49 degree, I find out the angle. Now I know the value of alpha from here, L and mu and L is given in the figure problem, and alpha I find out. You put the value in t mean equation, that is this equation, and then we get the time, that is 2 alpha, that is 49, and cos alpha sin alpha, that is 49 2 alpha, then you get t means 1 second. So I already solved this problem, and you can see the derivation and take the picture. Okay, thank you.